Okay, so we're going to start looking at limits at infinity. So if we ask about what happens as not only x goes towards something specific, but what about if x gets bigger and bigger and bigger and bigger? What if x tends towards infinity? And we'll take one of our little example functions here. Maybe this, maybe the first one, 2x squared plus x over x squared plus 1. So if we ask about what happens as that goes towards infinity. So a couple different things. I have this review of the horizontal asymptotes up here because you don't have to have these memorized. We can certainly graph it and do things numerically as well. But you just notice there's a pattern of these that since we're making it bigger and bigger and bigger, so we're going, in this case, really far to the right, or what happens if we do negative infinity, which would be really far to the left, those are the same behavior, right? The end behavior from pre-calc of horizontal asymptotes. But even if you're 99% sure you think you know what it's doing, it's always worth taking a look at. Picture's worth 1,000 words. So we could graph this and we could look at the table. Maybe we'll do all three just for safety's sake. All right, so 2x squared plus x over x squared plus 1. So first I'll just look at the graph. And we can kind of notice, right, we're only looking 10 to negative 10. So something weird could happen after the fact, but it does seem like the height of these is sort of tailing off, right? It's kind of stopping at a certain point. And so it looks like there's some number it's tending towards. Now, if we just use our thing from horizontal asymptotes, the only time you get a horizontal asymptote that's anything other than 0 or none is if the degree of the top and the degree of the bottom are the same, in which case, if you remember, the horizontal asymptote is the top leading coefficient over the bottom. So that would say that this is going to tail off around 2. But another way to kind of verify that is if we go to the table and we want to say, what happens when we make x bigger and bigger and bigger? A lot of times I like to go to the table settings and just type in my own numbers. In fact, maybe we'll do that. Because even if you start scrolling, I know 100 feels like a big number, or 1,000, but we're talking infinite here. And so sometimes to get a really good idea of the pattern, it might be a good idea to say, what happens when we put in 10, like 1,000, maybe like 100,000 or 1,000,000, right? We're trying to make x bigger and bigger and bigger and bigger. And then be careful, I'm going to scroll over here too. It'll round up, see how like it'll run out of space. So it's not, these aren't quite 2, it's 2.000, but we can see the bigger we make x, right, towards infinity, it looks like x is, or y is getting closer and closer and closer to 2. And so we can say our limit as that tends towards infinity is 2. And then in this case, if we wanted to try, if they also asked us, let's say about like negative infinity, we could try the same thing, but really big negative numbers. So we could say what happens when we do negative 100. Oops. My negative was a little off the screen there. My button negative, I don't know, a whole bunch of zeros, right? We're just trying to get a pattern, so all that matters, they get bigger as we go. So it looks like it's near 1.989, then it's 1.99999, 1.9 repeating a whole bunch of times. So it does look like also as the graph on the left goes towards 2. So we can say the limit as x goes towards infinity is 2, and the limit as x goes towards negative infinity. Similarly, like if we had one from our horizontal asymptote thing, say if we changed our function a little bit, maybe like this second example one here. So 3x plus 2 over 4x squared. So before I even go to the graph, based on our horizontal asymptote rules, the degree of the bottom is bigger. And so that would mean that our horizontal asymptote is y equals 0. So I'm thinking this graph far to the right, right, towards infinity, we could do far to the left later, is going to head towards 0. But let's check and see if that's actually the case. So if we go to y equals, we type in our new function, 3x plus 2 over 4x squared. We take a look at the picture or the table. See how it's got this little, it looks like it's stopping at 0. Then this side it kind of comes from underneath, but it's getting so close to 0 it's almost blending in with the x-intercept there. And if we want to do negative infinity, just so I don't have to type again. Be careful when your calculator, this throws people off sometimes. So let's say we want to try negative infinity and see if it's also 0. See how here it's like negative 0.007 is a small number, not crazy small. It might be a good idea, in fact, let's try one of these a little smaller just so you can see what's going on. Negative, go 1,000. I guess that's as far as it's going to let us go. All right, so when this says e to the negative 4, what does that mean? It means your calculator, or e to the negative 9 even, or further one, your calculator is running out of space in that graph, and so it's switching to scientific notation. So negative 7.5 e to the negative 9 means negative 7.5 times 10 to the negative 9th in scientific notation. And so remember, negative means really, really, really small numbers, right? We're dividing by, or the reciprocal. And so that's really like negative point. We have to move this 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 0.000000000. So that is a really, really small number. And so it does look like it's tending towards 0. We can see it on the graph. So when it does that scientific notation thing, remind yourself, am I looking at a really, really, really big number, or am I looking at a really, really small number? Don't let the scientific notation thing throw you off. It's just your calculator runs out of space for a number with that many zeros in front of it. And so it pretty quickly here switches the scientific notation. See how at 2 decimal place there are 2 zeros, and by 3 or 4 zeros in front, 3 zeros, it already switches the scientific notation because it's out of space. And so same thing, the bigger we make this number, or in this case smaller, big small number, we're going towards negative infinity. If I make this bigger, see how that gets more zeros in front of it? So you can see the trend is what we care about for limits. We put in a bigger and bigger and bigger, or smaller and smaller and smaller, closer to negative infinity, our number gets closer to 0. And so we can say the limit as this goes towards negative infinity is 0. So I'd use all the tools at my disposal. But the basis of why this is happening as you go far left, far right, is it comes back to this end behavior stuff about horizontal asymptotes.